Today we're going to evaluate infinite geometric series. An infinite geometric series is the sum of the infinite geometric sequence. This series would have no last term. The formula to be used in solving for the infinite geometric series is S is equal to a sub 1 divided by 1 minus r, and the common ratio should be between negative 1 and positive 1. In this formula, a sub 1 is the first term and r is the common ratio. Let us try to evaluate each infinite geometric series. Give it a try and play the video whenever you're ready for the solutions. Question number 1. 81 plus 27 plus 9 plus 3, and so on. The first thing that we need to determine is the first term a sub 1 and the common ratio r. In this geometric series, our first term is 81 and the common ratio is 1/3 because you can do 27 over 81, 9 over 27, or 3 over 9. So the r here is 1/3. Since the common ratio of this infinite geometric series is between negative 1 and positive 1, then we can solve for the sum of this infinite geometric series by using the formula S of n is equal to a sub 1 over 1 minus r. Now let's substitute. Our a sub 1 is 81 over 1 minus 1/3. Simplifying this further, we have 81 divided by 1 minus 1/3 is 2/3. Now we will have 81 times the reciprocal of 2/3, that is 3 over 2. So the answer is 243 divided by 2. This is the sum of this infinite geometric series. Question number 2. 1 plus 0.5 plus 0.25 plus 0.125. First, we need to find the value of a sub 1 or the first term and the common ratio r. Our first term is 1, and what do you think is the common ratio? Common ratio is 1/2 or 0.05. And you can do this by dividing 0.5 over 1, 0.25 over 0.5, or 0.125 over 0.25. So the common ratio is 0.5 or 1/2. Since the common ratio is between negative 1 and positive 1, we can also find the sum of this infinite geometric series. We will be using S of n is equal to a sub 1 over 1 minus r. Substituting the values, our a sub 1 is 1 divided by 1 minus 1/2. Simplifying this, we have 1 divided by 1 minus 1/2 is, and of course 1 divided by 1/2 is 2. So the sum of this infinite series is equal to 2. Question number 3. 1 negative 0.6 plus 0.36 minus 0.216. So first we need to find our a sub 1 and r. Our a sub 1 or the first term is 1. And the common ratio here is negative 0.6. And that can be obtained by dividing negative 0.6 by 1. So the common ratio is negative 0.6. In fraction, this negative 0.6 is equivalent to negative 3/5. Since our common ratio is between negative 1 and 1, then we can find the sum of this infinite geometric series. We will be using the formula S of n is equal to a sub 1 over 1 minus r. Now let's substitute the values. Our a sub 1 is 1 over 1 minus negative 3/5, so that is plus 3/5. Simplifying this, we have 1 over 1 and 3/5, or the same thing as 8/5. And of course, simplifying this means we need to do 1 times the reciprocal of 8/5, and that is 5 over 8. So the sum of this infinite geometric series is 5/8. Question number 4. 3 minus 9 over 4 plus 27 over 16 minus 81 over 64. First, we need to find our a sub 1 and the common ratio. Our first term is 3, and common ratio can be obtained by dividing the second term by the first term 3. So this is the same thing as negative 9 over 4 times 1 over 3. Simplifying this, it's negative 9 over 12, or the same thing as negative 3/4. Since r is between negative 1 and 1, then we can calculate for the sum of this infinite geometric series. We will use the formula s of n is equal to a sub 1 over 1 minus r. Now let's substitute the values. Our a sub 1 is 3, divide by 1 minus negative 3/4, so that becomes plus 3/4. Simplifying the denominator, we have 3 divided by 1 and 3/4, or it's the same thing as 7 over 4 in improper fraction. Dividing this, we will have 3 times the reciprocal of 7 over 4, which is 4 over 7. Simplifying this, 3 times 4/7 is 12 over 7. So this is the sum of the infinite geometric series. Question 5. 81, negative 27, 9, negative 3. First, we need to find the value of a sub 1 and the value of r. Our a sub 1 is 81, and the common ratio is negative 27 divided by 81. Simplifying this fraction, we have negative 1/3. Since r is between negative 1 and 1, then we can find the sum of this infinite geometric series. We will use s of n is equal to a sub 1 over 1 minus r. Now let's substitute. Our a sub 1 is 81, divide by 1 minus negative 1/3, and that becomes plus 1/3. Simplifying the denominator, we have 81 divided by 1 1/3, or that is 4/3 in fraction. Dividing this, we will have 81 times the reciprocal of 4/3, which is 3 over 4. Now we need to multiply 81 times 3, that's 243, divided by 4. This is the sum of this infinite geometric series. Question 6. Negative 3 plus 12 over 5 minus 48 over 25 plus 192 over 125. First thing, we need to find the a sub 1 and r. A sub 1 is negative 3, and common ratio is 12 over 5 divided by negative 3. So this is the same thing as 12 over 5 times the reciprocal of negative 3, which is negative 1/3. Simplifying this, we have negative 12 over 15. The simplest fraction is negative 4/5. Since r is between negative 1 and 1, then we can find the sum of this infinite geometric series. We will use s of n is equal to a sub 1 over 1 minus r. Now let's substitute. Our a sub 1 is negative 3 all over 1 minus negative 4/5, so that's 1 plus 4/5. Simplifying this, we have negative 3 divided by 1 and 4/5, or that is 9 over 5. Simplifying further, we have negative 3 times the reciprocal of 9/5, which is 5 over 9. Now multiplying negative 3 and 5, that's negative 15, divided by 9. And the simplest form is negative 5 over 3 because you can divide both numerator and denominator by 3. This is the sum of the infinite geometric series. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.